Let's take a look at this section of practice problems. It says solve using elimination. We almost have an opposite match, kind of in two different ways. If we look at the x's, they match but aren't opposite. If we look at the y's, they have opposite signs but don't match. Changing a sign is much easier than changing a number. So let's just go through and multiply that bottom equation by a -1 to get our opposites. This equation will become -2x plus 9y equals +1. And then let's rewrite the top equation right underneath it to make it easier to see the two side by side. Now we can go ahead and add the two equations together. -2x plus 2x are gone. We've eliminated that variable. We have 12y equals 12. We divide both sides by 12, and y is equal to 1. We can substitute that value for y into either of the original problems. The top one looks a little bit simpler for me, so that's where I'm going to put it. We have 2x plus 3 times 1 equals 11. We know that that's really 2x plus 3 equals 11. If we keep solving, we're going to subtract 3 from each side. So 2x is equal to 8, and dividing both sides by 2, x is equal to 4. Don't forget to write your final answer. 4, 1 is the point of intersection for those two lines. In the next problem, we have opposites in that both x and y have opposite signs from the top equation to the bottom equation, but nothing matches. If we start by looking at the x's, there's no easy way to turn 3 into 5 or 5 into 3. I could multiply the top equation by 5 and the bottom equation by 3 to make -15x as our opposite match. But there's a slightly simpler option. Let's look at the y's. Although I can't turn 6 into 2 by multiplying, I can turn 2 into 6. So if we multiply the bottom equation by 3, it becomes -15x minus 6y is equal to -42. And bringing the top equation down, we can see that we have the opposite match on the y's. So when we add those two equations together, we have -12x equals -48. And if we divide both sides by -12, we have x is equal to +4. We can then go back to either of the original equations. I'm going to choose the top one. So I have 3 times 4 plus 6y equals -6, which is really 12 plus 6y equals -6. Subtracting 12 from each side, we can see that 6y is equal to -18. And dividing both sides by 6, we see that y is -3. Don't forget to write your final answer. 4, -3 is the point of intersection for those two lines. In the next problem, I'm looking at 2 and 7 and seeing that though they have opposite signs, they're not easily made to match each other. But 15 and 5 can pretty easily match if we multiply the bottom equation by a +3. They already have opposite signs, so I don't need to change the sign. 21x minus 15y equals, let's see, that's 30 plus 21 or 51. If I rewrite the top equation just so it's close by, I'm now ready to add those two equations together. 21x plus a -2x is 19x. -15y and +15y eliminate, and I'm left with a 19 when I add 51 and -32. Dividing both sides by 19, x is equal to 1. I can substitute that 1 in for either of the x's. It's really up to you which one you think is simpler. I think they're pretty equal, so I'm just going to go into the bottom here. That gives me 7 times 1 minus 5y equals 17. That's 7 minus 5y equals 17. Subtracting 7 from each side, -5y is equal to 10. And dividing both sides by -5, y equals -2. So our final answer is the point 1, -2. Right away, I see that my signs don't have any easy opposites. So I am going to have to multiply a negative number, and I can either choose to multiply the bottom equation by a negative 2 to make the y's match, or by negative 3 to make the x's match. Let's go ahead and use negative 2 because it's just a little bit smaller. So my bottom equation becomes negative 2x plus 6y equals negative 16, and my top equation just comes down to be right next to it. When I add my two equations together, I get x equals a negative 11, and x is already solved for. So personally, it looks a little bit easier to me to take this negative 11 and put it in the bottom equation. Negative 11 minus 3y equals 8. Adding 11 to both sides, negative 3y is equal to 19. Dividing both sides by negative 3, y is equal to negative 19 thirds. That's a little ugly, so we're pretty glad that that came up second in the problem. We've got the ordered pair, negative 11, comma, negative 19 thirds as our point of intersection. For 2x and 10x, we could multiply the top equation by a negative 5 and get an opposite match. If I want to make the y's match, I'll have to multiply both the top equation and the bottom equation. So I don't think that's the easiest option. Let's focus on the x's. We'll multiply the top equation by a negative 5 and rewrite it below the bottom equation. Negative 10x minus 25y equals, let's see, a negative times a negative is a positive. 20 times 5 would be 100, and 2 times 5 would be 10, so that's 110. When we add these two equations together, the x's eliminate, and we have negative 22y equals 132. If we divide both sides by negative 22, we get y is equal to negative 6. We can put that into either of the original equations. It's really up to you what you think is simplest. I'm going to go ahead and use the bottom one. So I have 10x plus 3 times negative 6 equals 22. Well, that's really 10x minus 18 equals 22, and we can add that 18 to both sides. If 10x equals 40, and we divide both sides by 10, x equals 4. So the ordered pair where these two lines meet is the point 4, comma, negative 6.